All right, since we got 20 problems to go through to review, I'm going to start. I will say before, and I'll say it again at the end if anybody comes in a little bit late. I will be on at 4 o'clock on Thursday for the final exam, and you'll have till 8 o'clock to do it. So I'll give you about 4 hours to do it. So even if you get in at 5, I'll give you 8 o'clock to finish it up. That's not going to be a problem on Thursday. So, all right. It's cumulative final, so it covers everything. The review is online, so you can do the review. And you should be able to see the answers and everything else for that when you go through and do it. So it'll give you some practice on it. I would suggest trying it before the actual test, so you have a general idea of what's going on and how the questions are worded and whatnot. But I'm going to go through all the 20 questions tonight too. So back to what we started at the very beginning. Volume of a rotated shape. So they give me my two equations here, and it says at y equals x plus 1 and y equals 0 and x equals 0, and we're going to x equals 2. So the nice thing is this one is just a simple linear equation that is being rotated. So if we want to look at this one quick, this is what it looks like. So that's the shape that's being rotated. So the formula for it, as you can see right here, definition of volume, is just the integral from a to b. So in this case, it's from 0 to 2 of the area. So the area formula for this one, so it's circle. So it's let me actually get this right there. So it's pi r squared. So we've got pi. The r is my radius, which is the equation right there. So in this case, it's x plus 1 squared. So we've got, then we're going to FOIL that out. So I got x squared plus 2x plus 1. So my integral is pi times x squared plus 2x plus 1 dx. So now we're just doing the integral of that one. These integrals are pretty simple. So we can pull out the pi, and then we're just going to do the integral of that part. So I've got x to the third over 3 plus 2x squared over 2 plus x. And we're evaluating it from 0 to 2. The zeros cancel everything out. So I've got 2 to the third, which is 8. So I've got 8 thirds plus 4 plus 2. So my final answer is 26 pi over 3. So remember, whenever you're doing your area, it's rotating, so it's a circle. So that's where the pi r squared comes into play. Questions with that one? All right. Excellent. So this one, so basically you're going to have one using the disk method, which is what we just did, and one using the cylinder method. So this one's dealing with the cylinder method. The way they word this question is a little confusing. They give you the equation here, but they give you the information actually in the problem. So my equation for this one is y equals 7x and then x minus 1 squared. So that's the equation that I'm going to be graphing. So it's going to ask you three pieces of information. It asks you what your circumference is, what your height is, and then it asks you for your volume. So remember, the volume formula is right there. A to B, 2 pi x f of x dx. Remember that's my circumference. And that part right there is my height. So once you're writing the formula, the actual information is already going to be given to you. So in this case, we're going from 0 to b, so it's 0 to 1. I've got 2 pi x, and then 7x, x minus 1 squared dx. So circumference, height. So basically, when they're asking those two questions, they're asking for them just to make sure you understood what the circumference and the height was, because we're dealing with the cylinder method for this one. Now I can do my integral, so I can pull out all the stuff that's just constants. So I can pull out 14 pi. And I have x minus 1 squared. So I can FOIL that part out right there. I get x to the third minus 2x squared minus x. I missed one of the x's. I'm like, wait, my angle's wrong. 4, 3, 2. I forgot the x in the circumference. All right, so we're going to do my integration for this one. So I got 14 pi up front. So I got x to the 5th over 5 minus 2x to the 4th over 4 minus x to the 3rd over 3. And we're doing it from 0 to 1. 0, everything cancels out. So I got 14 pi, 1/5 minus 1/2 minus 1/3. Plus. So I end up getting 7 pi over 15. Let me multiply it all out. Any questions or issues with those? Those are the only two questions from chapter 6. You're going to have to do one disk, one cylinder method for volume. All right. Next one, the next three questions are from chapter 7. There's actually there's three problems. One's an integration by parts. One's an integration, and then one you're going to use partial fractions on. So this first one is actually an integration by parts, but we have to modify it first. So we want to get this one down so it's a simple multiplication. So the first thing we're going to do is we're actually going to use a one of the trig rules. If I don't go over a trig rule tonight, it will not be on the test. So therefore, I'm going over this trig rule. It's probably going to be on the test. So I would write this one down so this way you have it to use on the test. The trig rule is sine 2 theta equals 2. Theta cosine theta. So this is the trig rule you're going to need. The reason we're using this one is it's going to take the sine and the cosine and give me one piece there instead of two functions. So this way I can do integration by parts. So we're going to modify this a little bit. So I have, actually, I'm going to use x's instead of t's just to make it a little bit easier. So we're going to change this to 1/2 times 2 sine x cosine x dx. So in essence, what I did is that part right there is that part right there. So by taking the half and multiply, or half times 2, I'm not changing the problem at all, but now I'm able to use that trig rule. So my new integral is x sine 2x. So sometimes to make your integrations a little easier, you have to modify the problem a little bit. And that's what you're going to see in the first two problems that we're going to do. All right. So next thing I'm going to do is I'm going to do integration by parts. So we've got u du and v dv. So I'm going to make, remember, the algebra part is always or not always, the algebra part's above the trig piece because it's going to disappear when I'm going down. So make the x there. So dau is just going to be dx. And then I will make this part here the sine 2x dx, which will turn this into negative 1/2 cosine 2x. So we've got my u du and my v dv now. So remember, integration by parts is uv minus integral of v du. So I've got x times negative 1/2 cosine 2x. minus the integral of negative 1/2 cosine 2x dx. So this is now that. I am leaving out the 1/2 for a second. I'll put the 1/2 back in at the end of the problem. All right, so now I can do the integral of my cosine of 2x. So cosine of 2x is, so this comes out to be negative 1/2 x cosine 2x. And this is now a plus 1/2. And then the integral of cosine 2x is 1/2 sine 2x plus 3. So now if I take that and I multiply it all by the 1/2 that I originally had, or that I had in front of my square root there, I get negative 1/4 x cosine x plus 1/8 sine 2x plus 3. And that's my final answer. Any question on an integration by parts? All right. Next one. So this one looks really complicated. It actually breaks down to be pretty simple if you do one step first. So one of the things that you can do when you have trig functions, especially if you don't have sines and cosines, is get them all to be sines and cosines. Because when I get things to be sines and cosines, nice things happen. So remember that cotangent of x is cosine x over sine of x. So if I take a look at the top, I have 7 plus 10 cotangent of x. So I can change that to 7 plus 10 cosine x over sine x. And then get a common denominator. I have 7 sine x plus 10 cosine x over sine x. And while that looks more complicated, it's not going to be when I do the next one. So that was the top. The bottom is exactly the same process that I'm going to do. So I'm going to change 10 negative 7 cotangent of x to 10 sine of x minus 7 cosine of x all over sine of x. So now that I have sine, if sine's on the bottom of both of them, it can cancel itself out. So this problem becomes this problem. So I have 7 sine x plus 10 cosine x over 10 sine x minus 7 cosine x dx. And now you might be going, well, wait, that's no easier. And I could say, I can see why you'd say that. But this is where the nice thing comes in. All this is really messy for me. So let's take u and make it the bottom. So if I make u the bottom, what's the derivative of that? So this now becomes 10 cosine x. And that part becomes plus 7 sine x. Oh, and I forgot to switch screen. So if I make u the bottom, 10 sine x minus 7 cosine x. If I take the derivative of that, 10 sine x becomes 10 cosine x. Negative 7 cosine x becomes positive 7 sine x. Those two parts are now the same. So I can now get rid of my whole problem. And this now becomes just 1 over u du. But let's find the pi over 4 and pi over 2, so I don't have to go backwards. So u of pi over 4. So I have 10 sine pi over 4 minus 7 cosine of pi over 4. Sine of pi over 4 and cosine of pi over 4 are the exact same thing. It's square root of 2 over 2. So it's 10 square root of 2 over 2 minus 7 square root of 2 over 2. So I've got 10 minus 7, which ends up being 3 square root of 2 over 2. And if I do u of pi over 2, pi over 2 for sine is 0. No, sorry, pi over 2 for sine is 1. Cosine is 0. So this becomes just 10. So this integral of 1 over u is just ln of u. And we're evaluating it from 3 square root of 2 over 2 to 10. So I get ln of 10 minus ln of 3 square root of 2 over 2. And you can leave the answer like that. So some of these is just literally playing around with them, figuring out ways, looking at ways to do it. The last one, or this one, it's just getting rid of cotangent, making a cosine, and sine kind of gives you a way to start working it down. And this one actually wasn't a special integral rule because we ended up just using u substitution for it. But breaking it down like this allowed me to do that. Same thing with this one. It's like by using this rule, we were able to take two of the trig functions and put it together. So then I can just use the integration by parts. So it kind of works out nice. So sometimes you just got to play around with the problem a little bit to figure out a method to use it. All right. Next one. This one's the partial fractions. So remember partial fractions, the first thing we're going to do is long division. See if I have anything, find out what my numerator or the quotient is, and then the remainder. So, but you do that when the exponents are this, the bottom is smaller or equal to the top. In this case, they're equal to each other. So I have 5x squared, x squared minus 4x minus 32, and then 5x squared plus 0x minus 6. So x squared goes into 5x squared 5 times. So now I multiply and switch my sign. So I have negative 5x squared plus 20x plus 160. So I get 20x plus 154. So my new integral is 5 plus 20x plus 154 over x squared minus 4x minus 32. Actually, I'm going to do one other step first. The other thing we're going to do is, remember, we want multiplication in the bottom, so let's factor out that bottom part. For those of you who don't remember how to factor, we're looking for two numbers that multiply to negative 32 and add to negative 4, which in this case is negative 8 and positive 4. So I've got x minus 8 and x plus 4. All right. So now we're doing the partial fractions. So we've got, we're going to just look at this part right here. So I've got a over x minus 8 plus b over x plus 4. So I've got a x plus 4 plus b x minus 8 equals 20x plus 154. So if I make x equals negative 4, I would get negative 12b equals 74. So b equals negative 37 over 6. And if I make x equals 8, remember, all I'm doing is just switching the ones in the parentheses to get rid of it. So I get 12a equals 314. So a equals 157 over 6. So my new integral that I'm doing is 5 plus 157 over 6 over x minus 8 plus, or minus actually, 37 over 6 over x plus 4. All right, so now we've got to do the integral of these. So the integral of 5 is just 5x. The integral of any linear term like this is just going to be ln. So it's plus 157 over 6 ln x minus 8. And then minus 37 over 6 ln x plus 4 plus 2. Final answer for that. You will not have to do, so your integration by parts is going to be like this. You're not going to have to worry about the double denominators, and there won't be any quadratics in the bottom. So it'll be a pretty simple integration by partial fractions. All right. Hold on one second. All right. Next 3 questions are from chapter 8. So we have one that's representing length of a curve, one's doing surface area, and then a probability. So this one is the arc length, the length of the curve. So we've got our formula for the integration right there. The length is the integral from a to b, and it's the square root of 1 plus the derivative of the function. Now this one's in terms of dx. The problem right here is in terms of y, so it's just going to be in terms of dy instead. So my integral, they're asking for it from 1 to 4. So my integral is from 1 to 4. Now we're going to do the actual square root part first, because that's going to make our lives a little bit easier. So let's look at the square root part. So I got to do the derivative of this. So I've got dy d, or actually it's dx dy is the derivative of square root of y is 1 over 2 square root of y. And the derivative of 2y is just so now I'm doing 1 plus that squared. I square that out, I get 1 plus 1/4 1/4y minus 4/2 square root of y plus 4. So I get 1/4y minus 2 over square root of y plus 5. And there's not much I'm going to be able to do with that. You can't really simplify that down at all, because those aren't squares that are going to add to the middle, so it's not a perfect square that we can do out. So my integral is just, if you want, since I can't really do it, just in case you screwed up anything here, since we're going to have to use a calculator to do this anyway, you can actually just go back and put in that part right there. This way you know that there was no mistakes when you're typing in the calculator. So now this one, we have to use the Desmos graphing calculator. So if you just start typing I integral, it'll come up. So 1 to 4. We have 1 square root 1 plus 2 I minus 2 squared, and then dy. When you're doing this, make sure you don't put the dy underneath the square root. Click out of it and then type the dy. Otherwise, you won't get the answer. So, and you can tell on this one, it actually tells you, so then use your calculator to find the length correct to 4 decimal places. Where if you look at the previous ones, it says evaluate or find the exact value. This one tells you to use a calculator, so you know you're going to have to use a calculator for the final answer. Next one. Notice how this one says find the exact area. That means you're not going to be using a calculator for this one. So since this one says use the exact value, that's how you can tell the difference between ones that are going to make you use a calculator and ones that are not. So hold on, I have no clue on my phone. Flaggy. I'm the kitty. All right. So it's rotating around the x-axis. Yours is not going to rotate around the y-axis, so you can use this exact same setup. This is the formula we're going to use. Notice, just like the length formula, we still have that square root piece that we're going to have to do. So let's deal with that part first. So my dy dx is three over 2x squared, and then it's minus 1 over 6x squared. So we're going to square that. So I get 9/4 x to the 4th minus 1/4, and then minus 1/4, and then plus 1/36 to the 4th. And I have 1 plus that whole thing there. So I'm going to end up getting 9/4 x to the 4th plus 1/2 plus 1/36 to the 4th. Now, since this says we're looking for the exact area, you know this has got to work out. So there's got to be a perfect square for this one. So this one ends up being 3/2x squared plus 1/6x squared. And then we do the square root. If it's asking for the exact area, you have to be able to get rid of the square root. Otherwise, you're not going to be able to do the actual integration. So use the context clues in the problem to help you figure out what you're going to do. Because in life, you're probably just going to be able to use a calculator to do the answer and get the values anyway, because even if you go out 4 or 5 places, you're probably going to be accurate enough for any application you're going to be doing. So now that we've got that part, we can plug into my integral. So we're doing from 1/2 to 1. It's 2 pi times x to the 3rd over 2 plus 1/6x. And then times 3/2 x squared plus 1/6x squared. So that's my integral that I'm doing. First thing you're going to do to this one is multiply it all out. So this way we get it in terms of individual terms, which makes my life a little bit easier to integrate out. So pull out the 2 pi, 1/2 times 1. We'll FOIL this out and we'll get 3/4 x to the 5th plus x over 12 plus x over 4 plus 1/36 x to the 3rd. Yeah. Do my integral. So we get 3/20, or sorry, 3/24 x to the 6th plus x squared over 24 plus x squared over 8 plus, that's actually minus 1/72 x squared, 1/2 to 1. Doing all these fractions out, which I would highly suggest using the Desmos calculator for, you end up getting 445/768 pi. I would highly suggest using the Desmos scientific calculator to plug in the x's or the fractions, because I would not want to do that out by hand. All right. Next one, let's look at a probability one. This is the formula you're going to need for the probability. This is the, remember that U is the mean or the average. So for this problem, we don't even have to really worry about the zero part. So it's f of t equals 1 over 1.1 e to the negative t over 1.1. That will be my function that I'm going to use to do my integration stuff. All right. So the first one, it's the integral from, they want the less than a second. So we're going to go from 0 to 1 of 1 over 1.1 e to the negative t over 1.1 dt. You can do the integral notation for this one. Or I mean, you could actually do the integration out. They're not overly complicated. But since you're going to have to use a calculator anyway to actually do the evaluation at the end, because you're not going to be able to do E in your head, and they don't want it in terms of E, they want it rounded to 3 decimal places, use Desmos, because it's going to make your life a little bit easier, and it'll do it for you. So the integral from 0 to 1 of 1 over 1.1. And then we have E to the negative t over 1.1 dt. So that's the first one. So that would be for A. The next one says it wants it in term from 0 or more than 3 seconds. So since we've already got it in Desmos, we change the base to 3, and we change this one to some really high number because we can't do infinity. So that would be for B. All right. C, we have to do it. So because we want the slowest 5%. So we really want to know where the integral is going to give me the 0.05%. So we've got the integral from 0 to, or actually from B to infinity, basically, of that integral. So we've got 1 over 1.1 e to the negative t over 1.1 dt. So we do have to do the integration for this one. Doing the integral for this, you actually get, it ends up being just negative e t over 1.1. So now we've got this in terms of, we can either do it from basically we want this to equal the 0.05 for the slowest 5%. So first thing we're going to do, actually don't worry about the negative side because I'm doing the other direction. So first thing I'm going to do is I have to look for my ln of both sides. So I have the ln of this is going to be just negative b over 1.1 because we plugged in the b equals the ln of 0.05. So b equals negative 1.1 ln of 0.05. So if we plug that into Desmos, we get approximately 3.295 seconds. So this one you have to do out the integration for it, and then you're solving it for the value you need. All right, that's chapter 8. Chapter 9. Chapter 9 was the differential equations, or the, yeah. So we were doing separatable differentiation. So this is the one where we're breaking up the u and the t first so we can actually separate out the two problems. So if we look at this one right here, first thing we have to do is we have to get rid of move those, the t's out so I can separate out the bottom. So I have du over dt equals 1 plus t to the 4th over, and I can take out the t squared, and I'm left with u plus u to the 4th. So now I can move my u plus u to the 4th over to the other side. And on this side, I'm left with 1 over t squared plus t squared dt. So I can do the integral of both sides. So the integral of this one comes out to be u squared over 2, u to the 5th over 5, du equals negative 1 over t plus t to the 3rd over 3 plus c. And that's my final answer because I can't solve for u. So really the biggest part of this one is being able to move, separate out the u and the t so we can actually do the differentiation. All right. One more differential. This one's got y prime in it. Remember, y prime is just dy over dx. So if we move this piece over here, I get dy dx equals negative x e to the y. So now, again, just like my last problem, I can do the split. So I get dy over ey equals negative x dx. So if we do the integral of both sides, I get negative 1 over e to the y equals negative 1/2 x squared plus c. Now, this one, I only have one y, so I actually can solve this one explicitly for y. So you want to do that. So the first thing I'm going to do is I'm going to move that e to the y up top. So it's going to be e to the negative y. And I'm going to, since it's negative on both sides, I can get rid of the negative sign. So this is just 1/2 x squared. And then it's minus. So I'm changing all the signs. So now I'm going to do ln of both sides. So ln of the whole problem. So I get negative y equals ln of 1/2 x squared minus c. And I bring the minus sign over, so it's y equals negative ln of 1/2 x squared minus c. And then that would be my final answer. All right, that's the first 10 questions. All right, we've got 2, 3. We've got 3 integral or series tests to look at, and then we've got radius of convergence, so the power rule, and then the power series. Those are the next 5. So we've got 3 questions for the tests. A couple of them actually tell you exactly what to use. Like this one tells you to use the integral test. So you won't have to guess what it is to use. And I'll give you what the other one's going to use in a second. So you'll have a general idea of what they're all going to use. So it's just remembering how to actually implement the test for it. All right, so remember the integral test says we need to make sure that it's continuous, positive, and decreasing. And then we're doing the integral. If the integral is convergent, then the series is convergent. So in this problem, we've got 10 over x or n to the 15th. Okay, there's no negatives in it, so I know it's positive. We're not dealing with 0, so I know it's continuous. And since there's nothing on top, the bottom's getting bigger, I know it's decreasing. So I don't even have to worry about testing the integral test to make sure that those are true. We know it's continuous, positive, and decreasing based on what we've got right there. So in essence, all I'm doing is the integral for it. So I'm doing the integral from 1 to infinity of 10 over x to the 15th dx. So I can pull the 10 out. So I'm just doing the integral from 1 to infinity of 1 over x to the 15th. So that integral is negative 1 to infinity. And if we're looking at this one, it works out extremely simple. If we plug in the 1, I get, so infinity is going to 0. And then it's minus a negative 10 over 14. So this is going to 10 over 14. Since the integral goes to a specific number, that means it is convergent. So that means the entire function. So this series is convergent. It does not mean the sum is 10 over 14. Okay, so that we do not know from that problem. So that was the integral test. All right. Next one. This one just says determine whether the series converges or diverges. It doesn't tell you what you're doing. I'm telling you, you're doing the comparison test. All right, so we're doing the comparison test for this one. So I'm going to take the biggest part on the top and the biggest part on the bottom. So I've got 13n squared over n to the 4th. And I'm just going to compare this to 1 over n squared. So 1 over n squared is the p series. So I know that it's p equals 2, which means this part converges. So question is this always going to be less than that? So if we look at that, I know that those are not, we can't tell that that's always going to be less than it the way that it's set up. So because I can't tell one way or the other, we have to do the limit comparison test. So remember the limit comparison test was a to the n over b to the n, the limit of that. If that was if that goes to a value, then it was convergent. So through and so we've got, so I've got 13 n squared minus 8 over n to the 4th plus 7 divided by 1 over n squared. So I've got the limit as n goes to infinity of 13 n to the fourth minus 8n squared over n to the fourth plus 7. So I'm going to divide everything by n to the fourth. So I've got 13 minus 8 over n squared, 1 plus 7 over n to the fourth. So this goes to 13. Since 13 is a finite number that is greater than 0, they both converge or they both diverge. Since I know 1 over, so b to the n converges. So that means an also converges. That's the limit comparison test. All right. Next one. This one is the root test. So remember the root test? We're doing the nth root of it. If that limit is less than 1, it's convergent. If it's greater than 1, it's divergent. And if it equals 1, we cannot figure it out. Since I'm telling you that it's the root test and it's telling you the root test is in the problem, it is not going to equal 1. So it'll either be convergent or divergent. So we can pull the 3 out so I don't have to worry about the 3. We're just looking at the n part in there. So I've got the limit as n goes to infinity of the nth root of 1 plus 1 over n to the square. So those two things cancel out. So I'm going to have the limit as n goes to infinity of 1 plus 1 over n squared. So that's the limit as n goes to infinity of 1 plus 2 over n plus 1 over n squared. We don't have to FOIL it out. This is that special one. So this is that. That's why it's to the end. Remember, I had that one. It was E equals the 1 plus 1 over n to the n. So remember that rule, probably going to come up. So this limit goes to E. So since e is greater than 1, so since the limit as n goes to infinity equals e, which is greater than 1, this diverges. So don't forget that little. All right. The next one, the next two, both are the power series problems. One is as a power series, and we want to find the radius of convergence and the interval. The other one is a function that we want to represent as a power series. So you are always going to use the ratio test to find the radius of convergence. So we've got our problem here, and we're going to use the ratio test for it. Remember, the ratio test, just like the root test, less than 1 is convergent, greater than 1 is divergent. And that's where we want to keep that piece of information. Equals 1 is inconclusive, but we need to actually figure out the, we're going to plug those values in to see if it converges or diverges at those points to come up with my interval. So first thing we have to do is our ratio test to find what the x value is going to end up being in this problem. So I've got the limit as n goes to infinity of 3n plus 1, n plus 1 squared, x to the n plus 1. And we're dividing it by 3n, n squared, x to the n. So I want to split some of these parts out. So that is just 3 times 3 to the n. N plus 1 squared, I'm going to keep. And then this is x times x to the n. So 3n, n squared, x to the n. So I can cancel some of these parts out. I can cancel the 3 n's out. I can cancel the x to the n out. So my limit as infinity is 3x. No, sorry, forgot my absolute value. 3 absolute value of x, and then it's n plus 1 over n squared. So if we just look, so the 3 absolute value of x is going to go out. I don't have to worry about that part there. So the limit as n goes to infinity of 1 plus 1 over n is just 1. So I have this limit ends up going to just 3 absolute value of x. So I know based on the ratio test that when 3 absolute value of x is less than 1, that it is convergent. So that's what I've got to work with now. So that means the absolute value of x is less than 1/3. So my radius of convergence is 1/3, because it's that value right there. My interval we're looking at right now, I would split this up. I'd get negative 1/3 is less than x is less than 1/3. So now I got to plug in the 1/3 to the actual problem to see what happens on those two endpoints. So if I do the negative 1/3, I have the summation of 3 to the n squared, negative 1/3 to the n. So I get negative 1 to the n squared. So that is divergent based on the test for divergence, because that one right there, the n squared, that limit is going to infinity. So it's divergent. So that was negative 1/3. And if I plug in x equals 1/3, I get the same thing. I end up getting basically just n squared, which I know is also divergent. So I don't have to do any equal signs there. So my interval is negative 1/3 to 1/3. This parentheses are. All right. Next one. So this one, they're giving me a function, and I want to represent it as a power series. So remember that we have this setup over here. So 1 over 1 minus x equals the summation of x to the n. So somehow I've got to get that function to look like that. So let's look at the bottom part first. Let's kind of not worry about the squared at the moment, because we're going to do something to get that squared. So I can take 1 over 1 plus 4x, which I can then rewrite as 1 minus negative 4x. I know that equals negative 4x to the nth power. So I know that works. That's there. Now, so I know that goes to that. So if I take this 1 plus 4x, so I don't have to worry about, I know that equals this. If I do so one of the options that we have, we can manipulate the problem, we can do the derivative of it, we can do the integral of it. In this one, I need to get the denominator to be squared. So I need since if we moved it up top, I'd have -1. I need that to decrease again, basically to -2. And differentiation will do that. Differentiation always takes 1 away from the power. So if I do the derivative of both sides of this, so we're doing the d dy, dx dy, of both sides, I get -4 over 1 plus 4x squared equals, and if I do the integral of, or the derivative of that, I get -4 to the n n x to the n minus 1. So I'm now at this. And remember, my original piece that I wanted was x over 1 plus 9x squared. That's what I originally wanted. Or not x, 9. 4. So I'm almost there. We've got the bottom. I'm missing that x. And I got a negative 4 here somewhere. So if I take and I multiply this whole thing, I multiply both sides by negative 4x over, and I'll put the negative 4 on the bottom. So I'm multiplying by x over negative 4. So I can cancel out the negative 4s, and now that is exactly what I have there. So I really just have to bring this part right here inside, and I have my power series. So I have negative 4 n minus 1. If I divide that by negative 4, I have, that's where the minus 1 comes from. And then I have that x is going to take care of that other one. So I have x to the n there. So you can leave it like that, or if we want to clean it up a little bit so you can get, actually, so you can get rid of that and there, it doesn't really make much difference. I'm actually going to leave it just like that. So that is your power series. Next thing they wanted us to do is find our radius of convergence. So your radius of convergence, if you cancel everything out from this, the radius of convergence is always going to end up being the number and the absolute value of x. So it's always going to be that. So I've got the absolute value of negative 4x, so that 4 absolute value of x has to be less than 1. So the absolute value of x has to be less than 1/4. So my radius is 1/4. So you're always just going to take the number and then the x, because the ends are all going to end up canceling each other out. when we're doing the ratio test anyway. All right. Good for chapter 11. We have 2 problems from chapter 10. We have 1 parametric and 1 polar. So parametric, it's going to be looking for the first derivative and the second derivative, and then where is it concave up or concave down. There's my 2 derivative rules. And remember, concave up is where the d squared or the second derivative is greater than 0, is where it's concave up. All right. So let's find our first derivative. So dy dx. So it's dy dt. So it's the derivative of dy dx dt. So the derivative of the y term, it is a product, so we kind of have to do the product rule for this one. So it's the derivative of the first, which is 1 times the second, so you get negative e to the t, plus derivative of, for the first, which is t, times the derivative of the second, which gives you negative 1 e to the t. So that's going to be minus. So subtracting there. Then the bottom is just the derivative of e to the t, which is e to the t. So if we simplify this one down a little bit, I can pull out an e to the negative t up there, and I'm left with 1 minus t over e to the t, which is e to the negative 2t, 1 minus t. So that's the first derivative. Second derivative. So the reason why I moved the e to the t up is I want a just a multiplication, so I can do the product rule for my derivative and not have to do the quotient rule for it. So that's why you move the e to the t up, so you don't have to worry about that part there. Because the second derivative, I have to do the derivative of that divided by the dx dt. So derivative of that, again, do my product rule. So it's the derivative of the first, which is negative 2, or negative 2 e to the negative 2t times 1 minus t. And then just this derivative of the first, or second times the first, so that's just 1. And I get negative e to the negative 2t. And that's all over e to the t. So again, I can pull out my e to the negative 2t. And I'm left with negative 2 times 1 minus t plus 1 all over e to the t. So again, I can simplify this down a little bit. So I get e to the negative 3t. And I end up getting 2t minus 3. Oh, that's not plus 1, it's minus 1. Yeah. All right. So I need to, that's got to be greater than 0 for my concavity. Since e to the negative 3t can never be negative, the only thing I have to worry about being negative, so the first one's always going to be positive. So I just have to worry about the 2t minus 3 is greater than 0. So 2t is greater than 3. So t has to be greater than 3 over 2 for it to be concave up. All right. That's your parametric equation. Polar. So polar's got 2 parts to it. It wants you to graph it and then find the area. It's going to give you pictures of the graph. So really all you're going to do is throw it in a Desmos so you can see what the picture looks like. So this one we've got 3 plus r equals 3 plus sine 4 theta. And we've got our picture. So the first part of it, just literally throw it in Desmos and get your graph. The other thing that you can do when you graph it is, again, make sure you're only doing the part that matters. So like if you're doing 0 to pi, we're not going to have the whole shape. If you're 0 to 2 pi, we have the whole shape. So we know our integral is going to go from 0 to 2 pi. So make sure when you're graphing it, it's not duplicating on itself. And that means you would only want to do 0 to pi. So just keep that in mind. So my area formula is just, so the integral from 0 to 2 pi, and it's 1/2, and then it's 3 plus sine 4 theta squared d theta. So I can pull out the 1/2, and I'm going to FOIL this out. So I get 9 plus 6 sine 4 theta plus sine squared 4 theta. Now I cannot do that part right there because that's the square root in there. So I want to do the half angle formula. So remember that sine squared 2 theta is 1/2 1 minus cosine 2 theta. So sine squared theta equals 1/2 1 minus cosine squared, or 2 theta. So I've got 1/2. So my integral is the 1/2 to the outside, 0 to 2 pi, 9 plus 6 sine 4 theta. And then we do plus 1/2, 1 minus cosine 8 theta. D theta. All right. All right, so we put the 1/2 and the 9 together, and we get 19 over 2. So now I can do my integral for this. So I got 1/2. I got 19 over 2 theta plus the six divided by 4 cosine 4 theta. Oh, minus sines and cosines. And then minus 1/16 sine 8 theta. And we're doing it from 0 to 2 pi. So the zeros will cancel out that one, but the cosine it does not. So we can't just necessarily get rid of things. So I got 1/2 times 19 pi. The cosine of 8 pi, when we keep going around, so that's in essence the same as 2 pi. So that's going to be 1. So minus 6 over 4. The sine of 8 pi is 0. So that one is gone. And then it's minus. The 0 part there is going to be gone. And then that one is going to be, again, still negative 6 over 4. So the 6 over 4s are going to cancel out. And I'm left with 19 over 2 pi. That's my final answer for the area. That's the polar problem. All right, let's 3 to go. We're almost there. These are our vector problems. So the first one is combinations of them. So a plus b and the lengths of them. So a couple things. Remember, the lengths are just basically the square roots. And then the combination ones are just either addition or subtraction from it. It doesn't matter if it's in terms of the vector notation there or the I, J, and K. The process is identical to it. It just depends on how you're going to write your final answer in the box. I know there was a little bit of problem on some of the tests in chapter 12 where it didn't give you all the symbols for some reason. So if that's the case, just let me know when you do the final. It should be fixed. I don't understand why it didn't work in some people's problems. It worked in other people's problems. So I'm assuming it's going to be fine. If it's not, let me know so I can look at your answer there and I can make a modification for it if I need to. All right, so the first one, a plus b. So all this is we're going to basically add them. So all right, so a plus b. So I've got 9i plus 7i. And then I've got negative 8j. And then I've got 7k minus 9k. So I've got 16i minus 8j minus 2k. So that's a plus b. Next one, we've got 9a plus 7b. So first step, multiply them, the a by 9 and the b by 7. So 9a equals 81i minus 72j plus 63k. 7b is 49i minus 63k. Then we just add them together. So 9a plus 7b is 130i minus 72j, and the k's cancel out. So that's my final answer there. All right, the lengths. So we're just going to do our square root of them. So the length of A is the square root of 9 squared plus negative 8 squared plus 7 squared, which equals the square root of 194. And we can't do anything with that. So that's the final answer. When you're doing the length of a minus b, do a minus b first, and then do the length of it. So we've got 9a minus 8j plus 7k. Then I've got negative 7i plus 9k. So I've got 2i minus 8j plus 16k. And then do the length of it. So I got 2 squared plus 8 squared plus 16 squared, which gives me the square root of 324, which you actually can do that, is 18. So when you get your square root, just plug it in real quick, see if you can do it to simplify it down. So 194, you can't do anything with it. So if I divided it by 2, I get 87, and 87 is a prime number. So there's nothing I can do with those. This 324, I would just type it in quickly in the calculator first, just to try and make sure it comes out to be a whole. If it doesn't come out to be a whole number, then simplify it down. That one comes out to be a whole number, so I don't have to worry about simplifying. Two more. All right, the next one is finding angles between vectors. So this is the dot product stuff. So when you're looking at this, we have, this was the original theorem, the dot product of A and B equals the length of A times the length of B cosine theta. If you switch it around a little bit, we're looking for the actual angle in this case. So I actually need the corollary for it. So we're going to use this one instead. So I've got cosine of theta equals the dot product of A and B over the length of A and B. So first step, find me the lengths of A and B, find me the dot product of A and B. So look for the length. The length of A is the square root of -2 squared plus 9 squared equals the square root of 85, which you can't do out. Length of B, we have 8 squared plus 15 squared. So we got 64 plus 225 is the square root of 289, which, if I remember right, is 17. Now the dot product of A and B. Remember to do the dot product. It is, we're multiplying the first terms and we're adding it to the multiplication of the second terms. So it's -2 times 8 plus 9 times 15. So I got -16 plus 115 equals 99. So the cosine of theta equals the 99 over 17 square root of 85. It wants it as exact and then the approximate value. So the exact is just the arc cosine of 99 over 17 square root of 85. And then the approximate, you're going to put that in your calculator. So we go back to Desmos. Arc cosine of 99 divided by 17 square root. Make sure it is in degrees, which this is not. I don't think I can change. Wait, hold on. Click there. There we go. In degrees. So when you plug that into the calculator, you get that. So that's the exact value. All right, last one. All right, so the last one is the cross product one, where they're looking for the area of a triangle formed by these 3 points. So remember, our cross product is the matrixy piece. So, however, the first thing we have to do before we do this problem is I need to find 2 vectors. So I need to find vector PQ and vector PR. So remember, to find my vectors, we are just taking away the values in the problem. So vector PQ, I have 2 minus -2. Oh, subtracted. So I've got -2 minus 2, comma 1 minus 0, and then 3 minus 2. So it is -4, 1, and 1. And the same thing for PR. I got 7 minus 2, 2 minus 0, and 4 minus 2. So I've got 5, 2, and 2. All right, so once we've got our vectors, now we're going to do our cross product. So the easiest way to set this one up, so the cross product of P and Q is I, okay. We do -4, 1, 1, and 5, 2, 2. So I've got 1, 1, 2, 1, 2. I, and then it's minus -4, 5, 1, 2, J, plus -4, 5, 1, 2, K. So I got 2 minus 2I minus -8 minus 5J plus -8 minus 5K. So I've got 0I plus 13J and minus 13K. So this cross product is 0, 13, -13. So that is my non-zero vector. And the last thing it says is find the area of the triangle. So the area of the parallelogram, one of the formulas for it, is just the absolute value or the length of the cross product. So I'm just going to find the length of this. So I have 0 squared plus 13 squared plus negative 13 squared equals 169 times 2. So I just want this because I'm going to break it up anyway. So the square root of 169 is 13, so it's 13 square root of 2. That's the parallelogram, and a triangle would be exactly half of that. So we're going to take that whole thing and we're going to divide by 2. So my triangle is 13 over 2 square root of 2. So that's the area of the triangle. All right. And that is every question on your final exam. Yes, go ahead.
I was just going to ask, when will this video be available for viewing? I'm traveling right now.
I will post it in probably about a half hour or so when it actually downloads, because it's going to be a little bit. And Scott, since you're traveling, check your email.
Will do.
All right.
Thank you.
No problem. Any other questions?